students, welcome to Sunil's tutorial. I'm Sunil Milwani and today we'll be doing this chapter called as network analysis. Let's see this. Let's see, we're doing question number 2 on page 368. I'll write the question down. Event 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6. Optimistic time is 6, 6, 12, 6, 12, 12, 18. Most likely is 6, 12, 12, 6, 30, 30, 30. Pessimistic. (24, 18, 36, 48, 42, 54). Right? Now the first thing that you have to do is make a time estimate table. Now for PERT analysis, the first thing you have to do is make a time estimate table. Let's make the time estimate table, guys. Activity 1 to 2, 1 to 3, 1 to 4, 2 to 5, 3 to 5, 4 to 6, 5 to 6. First, let's find out the expected time. How do I find out expected time? A plus 4m plus b upon 6, where A stands for optimistic time, M stands for most likely time, and B stands for pessimistic time. So, in the first case, it will be 6 plus 4 into 6 plus 24 upon 6. So when you solve this, you will get the answer for this as 9. Next, in the next case, it will be again 6 plus 4 into 12 plus 18 divided by 6. When you solve this, you will get the answer for this as 12, right? 1 to 3, then 1 to 4. For 1 to 4, it is going to be 12 plus 4 into 12 plus 30 upon 6. When you solve this, you will get this as 15. Next, for 2 to 5, it will be 6 plus 4 into 6 plus 6 upon 6. When you solve this, you will get this answer as 6. Next, for the next one, it will be 12 plus 4 into 30 plus 48 divided by 6. When you solve this, you will get the answer for this as 30. Next, 4 into 6, 4. This will be 12 plus 4 into 30 plus 42 upon 6. The answer for this will be 29. And finally, this is going to be 18 plus 4 into 30 plus 52 divided by 6. The answer for this is going to be 32. Right? This is going to be my expected time. Once you have your expected time, the next thing that you need to do is you need to find out variance. Let's see, how do we find out variance? Variance is given by the formula b minus a the whole square upon 36, right? So in the first case, it is going to be 24 minus 6, 18. 18 the whole square upon 36. 18 the whole square, that's 326 upon 36. Next, 18 minus 6, 12 the whole square, 144 upon 36. Next, 30 minus 12, 18. 18 the whole square upon 36. That is going to be 326 upon 36. Someone just check that, please. Next, 6 minus 6, 0 by 36. Next, 48 minus 12, that's 36 the whole square. 36 the whole square is 1296. 1296 upon 36. Next, 42 minus 12, 30. 30 the whole square is 900 upon 36. 52 minus 18, 42. 42 and this is going to be 36. 36 the whole square is 1296 upon 36. So thus my time estimate table is made. Once my time estimate table is made, the next thing that I need to do is make a network diagram. Let's see a network diagram, guys. They've given you from 1 to 2, 1 to 3, 1 to 4. So from 1 you have from 1 to 2. 1 to 2 is estimated time is 9. We call this as activity A. Then you have from 1 to 3 is 12 hours. The time is given to you in days. So 12 days, we'll call this as activity B. And then from 1 to 4 is 15 days. We'll call it as C. From where am I taking the time? I'm taking time from the time estimate table. Then from 2 to 5 and 3 to 5. From 2 and 3, we're going to go to 5. So from 2 to 5. 2 to 5, 6, we call this as activity D. From 3 to 5. 3 to 5 is 30, we call this as activity E. Then you have from 4 to 6 and 5 to 6. From 4 you have 6, which is 4 to 6 is 29 hours. We call this as F. And then from 5 you have 5 to 6, we call this as G, which is 32 hours. That makes my network diagram ready. Once my network diagram is ready, the next thing that I need to do is I need to find out the various paths. The various paths that I can have is A, D, G. Then I can have B, P, G, and then I can have CF. These are my 3 paths that I can have. Now, out of the 3 paths that I have, the duration of each path A, D, G is 9 plus 6 plus 32, right? 9 plus 6 plus 32 is going to be 32, 38, 38, 47. So this is going to be 47 days. Then BEG is 12 plus 30, 12 plus 30 plus 32, 62, 74. Right? Then CF is 15 plus 29. This is 44 days. Right? So my critical path is going to be BEG and my normal project completion time is going to be 74 days. So let's see this. Critical path. The path that requires maximum time is critical path, which is going to be BEG. Normal project completion time. Normal project completion time is given to you as 74 days. Right? Next, variance of critical path. Now, BEG is my critical path. If BEG is my critical path, that means I have to consider 1 to 3. 1 to 3 is variance is 144 upon 36. B, E is 3 to 5. 3 to 5 is 1296 upon 36. And G is 5 to 6, which is again 1296 upon 36. Right? So when I add this, this should come
2736.
How much?
2736.
2736 upon 36, right? Which comes to 76 days. Once I have this, then I can find out the standard deviation of critical path. How do I find out standard deviation? Standard deviation is nothing but square root of variance. So that is square root of 76, which will work out
8.71.
8.71 something it must be. How much is it?
7.
Excuse me?
It is 8.7272.
8.72 days. Okay. So I've got standard deviation. Now, this is the basic that is required in every sum. Now let's see what are the questions that they've asked us. They said draw PERT network and find out the expected project completion time. We've already done them. What project completion will have 90% confidence of completion? They're saying that 90% confidence of completion. I want 90% confidence of completion. That means my probability should be 90%. 90% means 90 upon 100, which is nothing but 0.9, right? Let's draw the bell diagram. If I draw the bell curve, 90%, right? The bell curve is divided into two identical halves. So one half is going to be 0.5. If I want 90%, that means on the other half, I need 0.4. So the table value that will be required, guys, the table value will be 90%. That is 0.9 minus 0.5, which is 0.4. That is the area required. Now, let's look at the table and find out what is this area. The table is given to you on page 433 or thereabouts. 0.4. I want an area of 0.4. Now the closest I can get to 0.4 is 0.3997, which is nothing but 1.28. Therefore I can say that Z is 1.29. We take a value slightly above that, 4015, because 1.28, guys, 1.28 was 0.3997 and 1.29 is 0.4015. So the closest greater value that I can have is 0.4015, therefore I will take that as 1.29. But Z, random variable Z, is given by the formula due date minus expected date upon standard deviation. So 1.29 is due date. Expected date, normal project completion is 74 days. Standard deviation is 8.72. So 1.29 into 8.72 is due date minus 74. So when you multiply this
11.2488
plus 74 is due date. So due date is going to be
85.2488.
Right? So 85.2488, which I can write as 85.25 days. Now my normal project completion time was 74 days, right? Okay. So for 90% confidence that my project will be completed on time, 90% confidence is at 85.25 days, right? Let's see the next part of the question. There is a huge penalty for exceeding project completion deadline of 4 days beyond the estimated completion time. What is the probability of being penalized, right? Penalty for exceeding 4 days beyond project completion. Right? Now, my normal project completion time is 74 days. Right? Normal project completion time is 74 days. The maximum slack that the company shall give me is extra 4 days. If I increase beyond extra 4 days, then I'll end up paying a penalty. Therefore, I can say that number of extra days given They are giving you 4 extra days. Therefore now penalty imposed if project not completed in 78 days. Now first let us find out the probability that the project is completed in 78 days, right? Let's find out the probability of project completion in 78 days, right? For which due date is 78, expected date we know is 74, standard deviation is 8.72. Therefore I can find out my normal variable z. Normal variable z is due date minus expected date upon standard deviation. 78 minus 74 upon 8.72, 4 upon 8.72. When you divide this, you should get this answer as 0.46. Now find out the area for 0.46, the table value for this. Wait, I'll just show you how this will appear on a bell curve. This is going to be my 74 days. This is 78 days. This is days, and the value of z here we found out is 0.46. So let's find out the area between the mean value and 0.46. Let's look at the table and get the area. 0.46 is nothing but 0.1772. area, table area is 0.1772, 3727, 0.17772. Now you also know that the area from the first half of the bell curve has an area of 0.5. So in that case, probability of 72 days is going to be 0.5 plus 0.1772. So that is 0.6772. That's the probability that the project will be completed in 72 days. So what is the probability that project not completed in 72 days? The probability that project is not completed in 72 days, whenever you have to do not is 1 minus the required. So 1 minus project completed, probability of project completed. So this is going to be 1 minus 0.6772. This is going to be 8.223, 0.3228.
Yes.
Right? So the probability that the project will not be completed on time is 0.3228. But if the project is not completed on time, you have to pay a penalty. Therefore, the probability that of penalty is 0.3228. That means there are 32.28% chances that you will be penalized for not completing your project on time. Right? Do we get this in clear? This finishes the sum. We'll stop this here for the day. Thank you very much.